The last part of P5 we need to talk about is completing the square. This is a new solving technique that on most SATs you would actually need to use to solve a question. It's something that will take a minute for you to absorb, so maybe you have to rewatch this video a couple times, but know that you are always allowed to ask questions of me. So the first thing we'll do is just review. If you've got something in parentheses squared, what does that mean? It means that there are two of that thing in the parentheses. So then to expand that, to multiply it out, we'll FOIL. The first, the outer, the inner, and the last. Now this is something that you guys are pretty good at. Some of you can do it in your head, but you'll get x squared plus 3x plus 3x plus 9. Combine some like terms, we'll get actually x squared plus 6x plus 9 completely. So maybe take a second, try this one on your own if you need to. But again, you have two of them. These are the terms you will generate. And you end up with x squared minus 8x plus 16. Now, this in general thing, I'm going to skip. Brinks teaches it a little different way than I do. That's okay. This other method is one that seemed to work better for people last year. So with this, I'm going to give some steps because we're going to make some comparisons between what's happening here and how you solve this. So let's make a steps list over here on the right. We're going to kind of figure out what's going on with this complete the square. Again, you might have to kind of see it the first time to have it set in and kind of get a feel for what's going on. So step one is to put the variables on one side of the equal sign and then numbers on the other. So that means here that I want to keep these x's on the same side. I'm going to choose to bump this -8 or bump the 8 over by subtracting it on both sides and making a -8 over here. Now you'll notice I intentionally left some space. So with this, we're going to find something to complete the square. So in order to find that number, it actually is always going to be b over 2 quantity squared. Now when I say b, I'm talking the number in front of x squared is a, the number in front of x is b, and the number being added or subtracted is c. So that means that if I'm trying to find b over 2 squared, I want to take the number 8, I want to divide it by 2, and I want to square it. So 8 divided by 2 is 4, 4 squared is 16, and this is what gets added to both sides. Now you might be going, why do we care about this? Well, in doing steps 2 and 3 of finding it and then adding it to both sides, this is where the name complete the square is going to be allowed to happen. So bear with me a second here, you'll be fine. So then what I want to do here is start to clean some of this up. So -8 plus 16, we know that that's 8. But step 4, really what its purpose is we want to rewrite the left side as something squared. This is where complete the square comes in. When we do this process, we're completing the equation so that you can write it as something squared. Complete the square to complete something to get something squared. But how do I know what that something squared is? Well, if I take a look at what we did up here, we started with something squared, something in the parentheses squared, and we got something out, and that looks a lot like what we did with this complete the square process. So here, we knew it was x minus 4 because a negative 4 and a negative 4 multiplied got me 16, and a negative 4 and a negative 4 added gives you negative 8. So I got to think here, what multiplies by itself to get 16, but also multiplies by itself to get 8? Well, 4 times 4 is 16, and 4 plus 4 is 8. So that positive 4 becomes the number that goes inside here. And now I've got something squared. If you don't believe that this is how you get it, just FOIL this out, see if you get this. You can always double check your work that way. But again, this complete the square is a solving technique. We want to get down to x equals, and now this looks like something we did up here, and we can solve it. I can square root both sides, so I get x plus 4 being left over. And then the square root of 8, I am going to go plus or minus the square root of 8. Now, could you also tell me the chunk down version? Yes, you could, but I don't think it's going to be any more useful than where we're going to end up. Because if I just take negative 4 and I bump it over, subtract 4 from both sides, bump it over, this answer is actually less to right than negative 4 plus or minus. You'd get 2 square roots of 2. So I would accept either answer there, because there's not really any further simplifying you can do. These are not like terms that you could combine. I would accept this. This is the process of completing the square. You'll see it took about 6 minutes to explain. Fairly complicated. Maybe you need to see it again. So let's try it again with example B. So this is the B that we're going to need, but first thing is to do the setup. Get the variables on both sides with the blanks, and get all the numbers to the right side with a blank. Step 2, find b over 2 squared. So b over 2 squared, b is 4, so 4 over 2 squared, 4 divided by 2, 2, 2 squared is 4. So I will add 4 to both sides. That's step 3. Step 4, rewrite the left side as something squared. Well, what multiplies by itself to get 4, but adds to itself to also get 4? That is 2. 2 times 2, 4. 2 plus 2, 4. And the positive keeps the signs the way it needs to be. The right side we clean up. We'll get negative 4. Step 5 is to solve. Forgot to write that out the first time, but that is our 5-step process to complete the square. Square root both sides. Leave us with an x plus 2 on the left. Square root solving. You need to think plus or minus. Square root of 4, we know to be 2. Square root of a negative needs to trigger an I. Subtract 2 from both sides. You'll get a minus 2 and a plus or minus 2i. So there. You can see that once you get the hang of the process, it'll go a lot quicker. You might still be like, wait, whoa, what's going on? Just ask me some questions about it. We'll do a couple more examples just to kind of build it up to kind of the SAT level you might see. So here, this was in the P2 notes. It said, could you find the center and the radius of an equation like this? And it said the hint was to complete the square. Well, now we know what to do. We've got all the variables on one side. That's step 1 with a blank. And that's going to equal, if I add 12 to both sides, that'll be on the right, left a blank. Step 2, find b over 2. Well, here I've got b. B is the number in front of x. So there's b, negative 4 over 2 squared. Similar to this, negative 4 divided by 2, negative 2. Negative 2 squared is 4. So I will add that 4 to both sides. But you might be saying, hold on, there's a y. How is this changing things? Well, you can complete the square once for each variable. The goal is, do you have it in a way that you could write it as something times itself or something squared? So, do I know something multiplied by itself that will give me y squared? I do. That is y times y. So we do not have to complete the square here. We're trying to figure out what we have to do to get this kind of figured out. So if I regroup this, x squared minus 4x and the 4 that I added, then I've got the y squareds. That equals 16. This I can rewrite as x minus 2 squared. Here, negative 2 times negative 2 will give us a positive 4. Negative 2 and negative 2 will get us the minus 4. Again, y squared is y times y, so we can leave that equals 16. Now this looks like the standard form of a circle. That is where we got the center and the radius from. So the center here, remember h comma k, so inside I'd see a negative 2, the h is a positive 2. Here, the invisible number being added or subtracted is a 0. And then the radius, if this is r squared, that means my radius would have to be 4 if I were to take the square root. So that's another use of complete the square. It actually helps us write equations of circles in a different way. Last thing with complete the square, let's go to that SAT style question on the last page. So you'll notice now you've got some x's and y's together. You've got an x squared and a 4x. You've got a y squared and a minus 2y. And you've got the minus 1. Now, because you don't know what times itself can get you both of these things, this is where you're going to need to complete the square once for the x's and once for the y's. So that means you're going to have to do the process twice. You're going to add something twice. So b over 2 squared, 4 over 2 squared, we've seen this before, ends up equaling 4. We'll add 4 to both sides. For this one, the b is negative 2. It's that number in front of y. So negative 2 over 2 squared, negative 2 divided by 2, negative 1. Negative 1 squared is a positive 1. So now I will add 1 to both sides. Now, the right side is all I really care about, because the question it's asking us is what's the radius? So here, negative 1 plus 4 plus 1, those are opposites. They offset each other. This will end up being the r squared to get 2. Now, how did I make that jump so quickly? Well, I know that my goal is to rewrite this as something squared and then this as something squared. This, what multiplied by itself gives you 4. That also adds to 4. That's a positive 2. So x plus 2 squared. And then I will add that to what times itself is 1. That adds to negative 2. Well, negative 1 and negative 1 multiply to positive 1. And negative 1 and negative 1 multiply to negative 2. So as I rewrite this, I'm seeing, oh, there's the equation. Something squared equals that. All I care about is the radius, so I care about the right side. So if that's r squared, I will take the square root and get 2. If you have questions about that, let me know. The official homework for P5 is 1 to 11 odd, 13, 14, 16, 19, 21, 23, and 25 to 28. Let me know if you got questions.